You're walking down a dark hallway in your own apartment at night, just going for water, something you've done 1,000 times before. Your feet know the route better than your mind does. And then something moves by the wall. You've already jumped back, heart pounding, palms sweaty, before your conscious mind finally catches up and reports, a little late, that it was just your own jacket, snagged on a hook. The real question is who exactly made the decision to jump. Because it definitely wasn't you. Not the version of you reading these words right now, anyway. And here's what's even stranger. A split second before you jumped, your body didn't just react. It froze first, as if for one heartbeat it turned to stone. Let's figure out why. This is where the real puzzle begins. We like to imagine that we see danger first, feel afraid second, and our body reacts last. But experiments show the opposite. The body bolts and freezes before the visual cortex has even finished figuring out what it's looking at. And this isn't one neat trick of the nervous system. It's several layers of protection stacked on top of each other, polished not over years, but over millions of years. And each layer turns out to be stranger than the one before it. Let's start with the mechanism itself. Deep in the brain sits the amygdala, a small structure roughly the size of an almond, which is exactly where its name comes from. It receives information through two very different routes. There's a long path through the visual cortex, where the picture gets carefully analyzed, identified, and understood. And there's a short detour through the thalamus, something like the brain's sorting office, which routes raw signals from the eyes, ears, and skin. That shortcut is sometimes called the low road, and it's crude, blurry, and prone to mistakes. But it's fast. Think of it like a phone that shows you a low-resolution thumbnail before the full image finishes loading. The amygdala looks at the thumbnail first, and based on that blur alone, it's already willing to sound the alarm. Now let's talk about what happens in the body in those first instants after the alarm goes off. Before you run or fight, there's a short pause that scientists call the freeze response. Breathing stops for a beat, muscles tighten, the eyes lock onto the target. This isn't a glitch, it's an old tactic. Many predators are built to respond above all to movement, so freezing for a fraction of a second effectively makes you invisible for a moment. Only after that pause does the more familiar fight or flight pair kick in. And if neither of those helps, the body has a third, more extreme option in reserve. A kind of temporary shutdown, almost a feint, the same trick some animals use when they play dead. Humans experience a milder version of this too, in the kind of freeze where, in a genuinely dangerous moment, a person simply cannot move or scream. And here's a layer almost nobody brings up in these conversations. The neuroscientist Joseph LeDoux, one of the first researchers to map this short neural pathway in detail, ran experiments on rodents, showing that even animals with a damaged auditory cortex still flinched at a sudden sound and learned to treat it as dangerous, which means part of the brain can recognize a threat and generate a fear response entirely without the region responsible for conscious awareness. Your body can, quite literally, know before you do. This, by the way, is exactly what a huge chunk of horror movie language relies on. A sudden jump scare doesn't work because the audience has time to be frightened by the story. It works because the amygdala reacts to a sharp sound and abrupt motion before the viewer has consciously registered what's on screen at all. Now let's talk about where all this urgency comes from in the first place. Hunter-gatherers on the plains of the Pleistocene didn't have the luxury of carefully analyzing a rustle in the grass. If it turned out to be a lion and you'd decided to first confirm the silhouette, weigh the odds, and cross-check your memory, you simply wouldn't leave descendants behind. Evolution never cared about accuracy. It only cares about surviving long enough to reproduce, which means it was cheaper to be wrong 1,000 times, mistaking a stick for a snake, than to be wrong once in the other direction. Psychologists sometimes call this the smoke detector principle. A cheap, oversensitive system that shrieks at burnt toast still beats an expensive, precise system that occasionally misses an actual fire. But here's where things get even stranger. In people with heightened anxiety, this short pathway seems to run permanently keyed up, its trigger threshold lowered, and the amygdala fires far more readily over small things. Functional MRI studies show that in people with anxiety disorders, The amygdala reacts more strongly and to milder stimuli than it does in everyone else. That's where the sense comes from that an anxious person jumps at everything. From the nervous system's point of view, that's not a character flaw. It's a slightly different setting on the exact same ancient mechanism, roughly like a microphone whose recording level got accidentally turned up. And here's something that almost never comes up in these discussions: just how heavily this whole system is shaped by past experience. The amygdala is a fast learner, and it can learn from a single event. If a particular breed of dog bit you once, your brain may well flag as dangerous not just that specific dog, but the entire visual category attached to it: a similar silhouette, a similar bark, even a similar collar. This is called fear generalization, and in that sense, your nervous system behaves like an overly cautious editor who, after spotting one typo, starts suspecting practically every word on the page. This is the point for an honest caveat. This system is far from perfect. It regularly gets things wrong, mistaking a garden hose for a snake and a jacket for an intruder. And in the modern world, where actual predators rarely lurk in stairwells, it often just wrecks your nerves for nothing, reacting to an email from your boss with nearly the same intensity your ancestors reserved for a rustle in the bushes. On top of that, the balance between the fast and slow pathways differs across people and across species. Science is still refining the details of exactly how this circuitry works, and it would be a mistake to think the entire range of human fear boils down to one shortcut in the brain. It's just one mechanism inside a far more complicated system. And now, the twist this whole thing was building toward. That split second in which your body reacted before your conscious mind means that part of the decision making about your own life is handled by a structure that, evolutionarily speaking, is older than language itself, older than logic, older than the you listening to this right now. What's more, a similar shortcut pathway has been found across an enormous range of animals, from rodents to birds, which means this fear system predates not just human speech, but the very split into separate species we're used to thinking in. In a sense, you're sharing your skull with a very old sentry, one who was already standing watch back when nothing on this planet could have called itself human, and who is still standing that same watch today, acting as though you live on an open savanna rather than in an apartment building. So the next time you flinch at your own jacket in a dark hallway, don't laugh at yourself too hard. For that one fraction of a second, something inside you woke up that spent millions of years keeping your ancestors alive until morning. It just hasn't quite gotten the memo that times have changed. And honestly, that might deserve a little more gratitude than you usually give it.